Hello. In this video, I want to show you an example of how to do an independence test, and we're going to use the multiplication rule. So remember from our last page of notes, this rule that the probability of A and B is equal to the probability of A times the probability of B if the events are independent. So we can turn around and use this as a test. If this is true, then the events are independent. Now, the equal part is really just for theoretical probabilities. Remember, everything's perfect in theory. So for theoretical probabilities, we're not doing an experiment or, actually drawing things out of a bag or flipping coins, whatever. Then if the two sides of the equation are equal, the events are independent. If they're not equal, it would be dependent. With data, though, or empirical data, that's a different story because we have variation. For example, in this situation where we have an experiment with two different treatments and a placebo group, we have 72 people here. And if we repeated the experiment with another 72, or 115, we would get slightly different results because they're different people. So we have to keep that in mind. With empirical data, we have variation. Sometimes called sampling error, but it's really a normal expected thing to have this variation. Okay, so they might not necessarily be exactly equal, but if they are close, the two sides of the equation, they're independent. Okay, if they are significantly different, they're dependent. Okay, so how close is close? We will talk about that in just a second. Let me get down to this. So first I'm going to write out my rule. Probability of A and B, is that equal to, it's a question, so I'm going to put a question mark, probability of A times the probability of B. Now the first thing I want to do is put in my events for this particular problem. So A and B, we really could choose any of these and probabilities. Remember, the and is the intersection, so those are all the interior numbers table. I'm going to pick the first one. I'm going to pick, because I kind of want to know what's the chance someone has a relapse. So talking about relapse and if they're using the dizipramine treatment. Okay. I'm going to use the probability of D and R. They're using dizipramine and they have a relapse. Is that equal to the probability of B times the probability of R? Okay, so let's fill in our numbers. The probability of D and R is that intersection, 10 out of 72. And is that equal to the probability of dizipramine? So that someone in the experiment was taking dizipramine, that is this whole row, right? So that total is 24 out of 72. That's called a marginal probability. Times the probability that somebody has relapse. The relapse column is right here, that 48 total people, 48 out of 72. Okay, so let's plug in our numbers. Let me clear my calculator. So 10 out of 72 is 0.1389. Okay, I'm going to leave this blank because I don't know what's going to happen yet. And for this side, there are several ways you could do it. You could divide each, then multiply. You could go straight across and then divide. I'm going to put in both fractions with parentheses. That feels like the easiest to me. 24 divided by 72 times parentheses 48 out of 72. And that is 0.2222. Okay, what do you think? How do those look to you? I'm thinking they look pretty different, right? This is almost 14%. This is a little over 22%. quite a big difference in there. So I'm going to write not equal to, okay? However, this is a judgment call at this point, okay? If they were a lot closer, say 1389 and maybe 0.1421, then I might put approximately equal to. Or if they were exactly equal or not equal. So these are our possibilities. Okay. So let's go ahead and write our conclusion out. The probabilities are significantly different. So having a relapse is dependent on the type of treatment. Or you may also write not independent. It's kind of a double negative. Not independent is dependent. Okay, so you might be wondering, well, how am I going to decide what is significantly different or not? We don't have all the tools to do that yet. So for right now, it's a judgment call. We're just getting at the concepts here. So you might say, let's say they were a lot closer. You might say they're close, so they're independent. And another student might say they're different, so they're dependent. So that is okay. That's why you just explain your reasoning, and then I'll accept either one. It is a judgment call. And you might also be wondering, well, if I used a different grouping, a different and probability, I might get different results. And you're right about that too. So right now, this is really a crude test, just to get to the idea of what does independence mean, how can we test for it. In Math 244, there is a significance test that uses all the numbers in the table, and that is really fun. So I hope you take that class. But we just don't have enough tools for that quite yet, but it's really important to understand this idea of independence. So thank you for watching this, and I'll see you in the next video.